Now we're going to start on part 8 of Project 6 in part 1 of Project 6. So we have our correlations and our fund pairs, the two fund pairs, or three fund pairs that we're going to use for our portfolios. So I'm going to show you how to do one portfolio, and you're going to do the other two yourself. And then I will stop after 15 because part 2 is crystal ball, and you're going to have to learn that in the classroom, in the trading lab. So let's get started. So you're going to make portfolios of each of the fund pairs in step 6. So to do that, you're going to open a new worksheet, and we're going to add the data for the first pair of funds by cell referencing and dividing by 100 the returns, averages, and standard deviations. And it's easier than it sounds. So let's first look at this picture. So here's the picture on how it's going to look. So portfolio 1 is the one with the two funds with the highest standard deviation. So I want to put the correlation coefficient, I want to put the fund type, and I want to put the fund name. So first I'm going to cell reference the correlation coefficient, which is right here, and I'm going to cell reference the fund type, but I'm going to do that by looking here FPBFX. I'm going to come up here and find FPBFX, and because I already have these sorted in order by standard deviation, it's going to be at the very end. So that one, and it's an international fund, so that's what I'm trying to get. So I'm referencing that, and I'm going to cell reference also the fund ticker, and I'll do that for the next one too. Now we know that since they're in contiguous columns, I can just drag this over and there will be the correct fund. Now I want to cell reference the fund return right here, but not just the return. I'm going to do the return divided by 100, because the way that FactSet gives them to you, they are in percentage form, and you want them in decimal form. No. So all the way down here, and get the end. Then I'm going to get my mean and standard deviation. So this one is blank, right? Now for your other fund portfolios, you're not going to be able to do it quite this simply, because they're not going to be in contiguous columns. These are in contiguous columns because I sorted them. So don't get confused there. Just go ahead and make sure that you've got the right fund and the right return, and make sure that you divide by 100. And then we've got this annual contribution, which is actually supposed to be here, and weight. And I'll tell you about those in a minute. First I want to tell you to do this. So for these two columns here, I'm going to copy them. So right click copy, and then I'm going to right click right here and paste special values so that they're no longer doing division, and because I don't want them cell referencing each other. And the reason for that is because of the crystal ball stuff that we're going to do. Crystal ball doesn't like it when we do that, so we're not going to do it. So I'm going to format them as percentages with 2 decimal places. And I've already written up here annual contribution and weight. The annual contribution is what I'm going to assume that I'm contributing every year. I'm putting 5,000. And the weight is the weight of Fund A in my portfolio. So I'm going to put 50% of my portfolio in Fund A. For the first year that I contribute, which is the first year in the data set, I'm going to put the 5,000, I'm going to multiply by 1 plus the portfolio return. And as we know, the portfolio return is going to be equal to the weight in Fund A times the return of Fund A, plus the weight in Fund B, which is 1 minus the weight in Fund A, times the return. Oops. The return in Fund B. I know I've said that 3 times. Now it's good. Okay? So it's the 5,000, which I contributed at the beginning of the year, times 1 plus the weight in Fund A times the return of Fund A plus the weight in Fund B, which is 1 minus the weight in Fund A, times the return of Fund B. So now, for the second one, I have to take, open parentheses, don't forget because of order of operations, I have to take what was in there before and add what I'm contributing for the year, close parentheses, then multiply it by 1 plus this weight. Now I'm going to anchor. I'm going to use my anchoring so that it doesn't move, because I'm now going to be able to pull the returns down, times, but I don't want cell referencing on, I don't want absolute referencing on this one, plus 1 minus this weight times the return for Fund B. And by the way, I have realized that I need to anchor this one as well. So I'm going to anchor this one as well, because that is the annual contribution. So that needs to not change. That's the formula, this one plus this one. And I'm going to take that whole quantity, and each time when I drag it down, I want that E3 to stay the same, because that's going to be added to the one above, because I'm contributing that amount every year. And then times the 1 plus the return for that year from that portfolio, 50% in each of these funds. Notice that stinks in this year, second year. But in the fourth year, it's pretty darn good. So that's how much money I'm going to have in the fund, and I'm going to make that formatted as a currency. So I'm going to have 172,268.87 in the fund. So that's what I'm doing for each of the three funds. Now you can make the weight different if you want. You can make the annual contribution different if you want. It doesn't really matter what you choose. The point will still be the same. Number 12 says, in the same row as your fund's average returns, calculate the portfolio's expected return using the weights and average of the returns of the two funds. So we know that the expected return on a portfolio is equal to the weighted average of the expected returns of the assets in the portfolio. I don't need to anchor because I'm not going to drag this down. So I'm calculating the expected return on the portfolio, which is the weight in Fund A times the return on Fund A, plus the weight in Fund B times the return on Fund B, expected return on Fund B. And now I need to set this. I need to use Format Painter to make that into the same percentage format as I had over here. Now I'm going to calculate the geometric average. So this is number 13. I'm going to calculate the geometric average by using the rate function, and it's 20 periods, so I just type 20 in. The payment is 5,000. The present value is 0, and the future value, I have to either make the payment or the future value negative. And I think I'll make the payment negative to get a positive rate, as you know, just like your calculator. I can put the type in a guess, or I can leave that blank. So 5.39%, and then the FV function, I'm going to use the FV function to calculate what the ending value would be if I made these annual deposits at the beginning of each year. So the rate is, the rate that I want to look at is the expected return that I just calculated. Number of periods is 20. Payment is this. Present value is 0. And type is 0, so we're going to just leave that. So let me come back up here. Oh, and I want to make the payment negative. So that the number is positive. So let me come back up here, and I'm going to type this in. Expected return on the portfolio. This is the arithmetic average, using the arithmetic average, so these two averages here. The geometric average, which is what I calculate when I use the rate function, and the future value at the arithmetic average. So the idea is this. What I actually would have gotten is 172,268. That's what I actually would have gotten if I had invested 50% in each of these funds starting 20 years ago. The geometric average, or the internal rate of return from contributing $5,000 a year for 20 years and winding up with 172,268, the rate of return that I earned, the internal rate of return, is 5.39%. So that's well below the expected return that I would have been able to expect, given that I have an arithmetic average return of each of these two in those two funds. So the future value, if I had earned this 11.27% and contributed $5,000 a year, would have been $331,000. As it is, it was only $172,000. Therefore, the portfolio manager is telling you that because on average you've earned 11.27% on this portfolio of these two funds over this time period, that you can expect to earn 11.27% and wind up with $331,000 from investing $5,000 a year is misleading at best. Really, it depends on the order of the return. So notice that you earned a negative 3.29% here, positive 71.89% here. These are very high standard deviation funds because I chose them that way. Then here I've got very high returns for both funds. Here I've got very low returns again. So these are risky funds. And the expected return is much higher than the realized return, or the geometric average internal rate of return, realized return, that I would have gotten had I invested in these two funds over the course of my investments. Okay, let me show you what would happen if I turn these returns around and had the exact opposite order of the returns, just in one of the funds. So instead of doing well in the fourth year, it did well in the fourth year from the time I retired. I mean, very well, over 100% return. So I'm going to finish turning these around. This is really the only way to do it. You don't have to do this part for your project. I'm just showing you something. Okay, so I'm going to substitute the exact reverse of the returns, and you can see what a big difference it would make if the returns were in reverse order. So you can see the return would have been 254 instead of 172. So the geometric average here is much closer because I had higher returns, or I didn't have those hugely negative returns late in the life of the portfolio. And I had, even though I had these high ones later, I had more positive returns early on in the life of the portfolio. And if I turned this one around, which as you could see was tedious to do, you'd see that that was even better. So the expected return is not, the arithmetic average is not indicative of what you'll necessarily get. It depends on the order of the returns and the timing of the cash flows and when you've made your deposits and how much you've got before you have a bad year and that kind of